looking at fiber optics now. So to begin with, what is an optical fiber? So this is something which works on the basis of the idea of total internal reflection, which also we'll be looking at in a couple of slides. So basically an optical fiber is a thin cylindrical dielectric waveguide which guides or transports optical signals by TIR. So thin cylindrical is self-explanatory. By dielectric we mean that it is not affected by any electric field or the changes in voltage or current. So this is, as the name suggests, it is optical fiber. It deals with light, and it does not run on electricity first of all, and it is not affected by electricity either. That's what we mean when we say dielectric here. And waveguide is basically a material which provides a path for a wave to travel through, a wave of signals. It generally can be any type of signals. It can be a light wave, a sound wave, a magnetic wave, an electrical wave, anything. So a waveguide is basically a path through which a wave can travel. And in this context, because it's optical fibers, we'll be looking only at light waves. So an optical fiber is a thin cylindrical path through which light waves can travel based on the phenomenon of total internal reflection. And it consists of three main parts: the core, cladding and outer coating. So outer coating is just to protect the fiber from getting damaged by weather or by usage, contact with human beings or vehicles and so on. The core and cladding are the more important parts which we use for TIR. So both of these are made of glass or some such material, but the core has a higher refractive index and the cladding has a lower refractive index. So why is this important? Let's take a minute to remember that when I say a material has high refractive index, I mean that it is a denser medium. In other words, the speed of light in this medium is slow. And when I say it has low refractive index, I say it's a rarer medium, meaning the speed of light in this medium is fast comparatively. So why is this important? Because you have the core on the inside, and outside it you have the cladding. So you need the slower medium on the inside and the faster medium on the outside. That is when TIR will happen at the core cladding boundary. If it was the other way around, TIR would not happen and you would lose the signals you're trying to transmit through light. So we need to remember that the core is a material having high refractive index and cladding is comparatively lower refractive index. And this is the basic structure of an optical cable.